So anyway, welcome to the Science Circle, and today we're going to talk about World Space Week, or not, and I'll explain what that means. Now, the theme of World Space Week this year is living in space, so we thought it appropriate to talk about the Moonbase project that we've been working on for 3 years now. We meet every Monday at this same time on Mondays, but let me show you what I mean. Okay, so in 1999, around the time that they were beginning to construct the International Space Station, the UN proclaimed that the week of 4 to 10 October would be called World Space Week. Does anyone know what I've asked this before, but there's new people. Does anyone know what the significance of those two dates are? I like to ask the audience so I know they're not out getting lunch or something, which is okay. Either one of those dates. Okay, well, that's fine. Okay, and that's why I asked, because a lot of people don't, unless they follow this closely. Okay, so the 4th of October in 1957, I believe, Mole Day. Yeah. Chemistry Day. Okay, great. Let's see. What is it? Now I'm trying to remember what it is. 2.92 times 10 to the... No, I'm showing my, 10 to 23rd, something like that. Okay, so anyway, yeah, there, 6.02 times 10 to the 23rd. Got it. So, okay. 2.92 something else. Okay, so anyway, the UN, the 4th of October in 1957 commences essentially a new age, if you want to think of it. It went from the industrial age to the information age. At least that's how one day we used to measure that, because it was so significant, because we meaning humans, put a satellite in orbit. It was actually the Soviets, but I'm going to be thinking of us as humans, because this is an international celebration. October, I believe 1968, was the day commemorating the Earth Peace Treaty, where nations, not everybody, but something like that, the nation's peace treaty, or the Earth Moon Peace Treaty, where people basically said, okay, we're going to when we get to the moon, we're not going to claim it for whoever gets there first. We're going to basically say it's kind of like Antarctica. Is hands off, you can use it for peace, etc., etc. Now, skip ahead 50 years, and the thinking is a little different in some corners of the world, but, you know, that's part of the reason why we're studying all this. But if you look at the slides there, it's got some very good ideas. It's the largest annual space event in the world. The UN was hoping to inspire students to be the workforce of tomorrow in science and technology, educating the public, international cooperation, all the reasons why I went into science and not politics. Okay, speaking of politics, if you go to NASA's Observe the Moon Night, which is also today, you will find this website that basically says, sorry, the government's messing with us and we don't have no one's home and we aren't updating this website, so you can't see all the great sites that are associated, the thousands of sites associated with Observe the Moon Night. But in theory, it's also, the concept is good, that people learn about inviting the whole world to learn about lunar science and exploration, honor cultural and personal connections, and to observe broadly, which is why we're participating. Okay, but it's really not, what we're talking about today is really not about World Space Week or Observe the Moon Night. It's about our group and what we're doing. And so, inspired by Observe the Moon Night 3 years ago, we formed the second Science Circle Moonbase project. basically asking the question, okay, if we observe the moon here, what would it be like on the moon looking at Earth? Or basically, what might it be like to live and work on the moon? So we've been approaching that question in different ways, and every once in a while reminding ourselves that the mission of the Science Circle is not only to foster science and investigation and such, but also to share what we learned along the way. So we've taken the opportunity, like World Space Week and Virtual World's Best Practices in Education and other things, to share what we're learning about living and working on the moon. It's also a exercise in critical thinking. Meryl's out there. Meryl is the editor of this in-world scholarly magazine. I'm writing an article about critical thinking for it. And what I have discovered is that our Moonbase project is really an exercise in critical thinking. Yes, it's partly intellectual curiosity, studying a real science problem, partly it's camaraderie and all of that good stuff. I'll talk later. Yeah, the Avatar Scholar, exactly. And so, which you can find their office over at the Virtual Worlds Education Consortium Island, just to our north. But more on that later, about the critical thinking part. So, what are we doing? Well, our first approach, by the way, like I mentioned, Sis, Sumo, Op, whoever, let's see, Emelok, Delia, other people have been in, Roy, Tagline, lots of people who have been in the project. Who else is there? Siri, who've been in the Moonbase project. If you want to pipe up about anything going on, hit the speak button and chime in. Okay, so our first approach to the question about how to live and work on the moon was all of these sorts of things, basically exploring the whole topic. Why? What do we do? Why? What would we need? What would we need to bring with us? You know, how do we get there? What's it like? What if we were there for months, not days, like the Apollo astronauts? Who should live on the moon? Should we just do some sort of lottery and those people go? Should it be billionaires? Should it be politicians? Should it be scientists? Should it be, who? Should it be just the people who fund it? How we get it funded? In other words, all of the types of things that you might ask about going back to the moon and living there. But our latest approach, we've decided, after learning quite a bit about the moon, and is to look at this kind of scientifically. Now, the interesting thing about looking at it scientifically is that our approach has been both quantitative as well as qualitative. I have PhDs actually in both areas, and so I'm schooled in both areas, but it's quite a shock to people who have been quantitative, in other words, the basic science lab sort of thing, to learn about how to look at things qualitatively, and social scientists to look at things physical sciences, all that good stuff like that. Wow. What does? You mean how to live there, or how to? But air pressure, for example, is one of the quantitative things we can look at. Yeah, exactly. There you go. Okay. Hey, but that's kind of a qualitative thing. I mean, it's quantitatively about how quickly your beer goes flat, but it's qualitative about why you need to be drinking beer in the first place. Okay, so we have a guiding question, which is kind of a qualitative approach, which is the one we began with, which is what might it be like to live and work on the moon? But then we wanted to turn that, there could be a brewery on the moon. I don't know how you'd brew stuff on the moon. Maybe that, there's got to be some ways to do that. Will there be beer? What would you make beer of? Yeast is actually probably fairly easy to grow on the moon. But hops, I don't know. Okay, so anyway, our research question is then, how might living or barley or whatever your beer comes, algae beer, there you go. You have to think of a name of that one, Dolly. Okay, so green beer. Oh, okay. Sis is a resident comedian, or is comedian a good word? In any case, he's very clever in coming up with yeah. Okay, on the moon. Okay, so the research question then is how might living and working on the moon be like or different as home on Earth? In other words, as a baseline. That can actually be answered as a research question in an article or whatever. Okay, so some questions to the research question, you can read them up there. Basically, which habitat should we study that might be more like living on the moon than living on Earth? And then also what features or conditions should we research and compare in the study? So that's kind of the scientific way of looking at it. So our baseline is basically, well, we could hard cider or soft cider. Okay, it all depends. Well, it is, and for lots of reasons, and we can go into that too. Even though the Apollo program tried different types of atmospheres, some to good success and some to drastic problems. Okay, so our baseline then is pretending perhaps that our home on Earth has our needs. It's able to satisfy our needs. As we know from around the world is that not everyone obviously has clean water, clean air, access to water, safety, security, all of the types of things that in an ideal world we would have. But the baseline then is an ideal home on Earth. Obviously that home there, which we made for Virtual World's Best Practice Education, is way bigger and fancier than most homes on Earth. But in any case, we are using this theoretical concept of home on Earth as our baseline to compare the moon and other habitats. Our goal, of course, is to understand better what a lunar habitat would be like. Learning that, of course, gravity is different. There's no atmosphere. If we do it in the right place, like the South Pole, there's water ice, perhaps, that we've discovered, constant sunlight, perhaps, building materials, all that. So what we decided to do this year was to explore places that might be more like the moon than the Earth. So, for example, Antarctica. Here again, I like to know who's out in the audience. So why would Antarctica, a base in Antarctica, be more like the moon perhaps than home on Earth, unless you happen to live in Antarctica or Siberia or other places? We actually had somebody who lived in Siberia with us the other day. Well, what do you mean? You mean like monsters from the deep, like movies? Let's see, whatever. What's the movie called where there was The Thing? Yeah, trying to kill it. Cold, okay. Now, not just cold, because there's people that live in cold weather, but deadly cold, as in the average temperature there is about minus 50 Celsius, sometimes getting down to minus 80 Celsius, which means that if you were to walk outside without full protection on, you would freeze things in minutes, okay? Meaning deadly cold. Okay, so cold. Yeah, no growing season other than ice crystals. In other words, lots of stuff. The other thing is it's at the, you don't want to freeze your things. Since it's at the South Pole, it's sometimes dark all the time. Penguins, yeah, but not at the South Pole. They need some fish. And there's not a lot of fish floating around at the South Pole. But you're right, penguins at about 1,000 kilometers or more away, space penguins. Very good. Okay, so anyway, think Antarctic base. So we were looking at these ones, and continue to look at a submarine. How is a submarine like? I'm watching my time because I'm going to try to keep all of this within an hour. How is a submarine perhaps like living on the moon versus living at home on Earth, unless you happen to live in a submarine? Well, yeah. In other words, for as Sumo is that there's a lot of stuff of these habitats that if you're not careful, well, you have to keep it pressurized, and there's pressure on the outside instead of a vacuum. So that's kind of the opposite. You have to essentially make your own air. Yeah, have to supply air, clean the air, make your own water from whatever water you have on board. In other words, it's a lot like a moon base or the International Space Station, and it's restricted. You can't just walk outside. However, it's different in that most of a submarine is not built for people living up there, but for mobility and its mission. Maybe a third of it's built for people actually living, but the rest is built for its mission, what it does. Okay, how about then the Starship spacecraft? How is it like a submarine or a moon base? Well, and there you go. Dolly has another one. Little room for air. You can't just go, oops, the door's open. Well, why not? Can we bring some plants? Oh, you mean from Antarctica? Not a lot of plants in Antarctica, but we can bring plants down there. They have a greenhouse in Antarctica, a nice one. Hydroponics, the whole bit, like Delia has created for our mock-up moon bases. But the Starship then is a little bit more like a moon base in that people would be living there for 3 months, and that essentially you would need everything. In other words, it's like a lot like a moon base in that regard, except of course a lot of it is for its mission, that is to get somewhere. So a lot of it is fuel and other things. Just like in a submarine, it's not all just people living there. It's for other purposes, and it moves. A moon base doesn't move a lot unless there's moonquakes. A submarine moves. A Starship moves. In other words, we're looking at how these habitats are like and different from a moon base in order to understand the moon base. That's really the whole purpose. It's not just looking at different habitats. So also Lunar Space Station or International Space Station. Now this is more of a hypothetical one. They're building a couple of the modules for this now, but the idea is that how is living in a space station around the moon different than living on the moon in a base? Are there the same hazards or are there different hazards? In other words, is it the same amount of space? All the different types of stuff, different ways of understanding living on the moon compared to things we know more about. Yeah, there you go, Dolly. That's exactly, yeah, that's part of the thing. In other words, we're looking at things we can kind of envision better because we know them. We know what living on, well, like I don't, because I haven't been up there. But I can go to videos of astronauts on the International Space Station talking about the International Space Station, showing how they eat and that sort of thing. So we can kind of envision how it might, and then we can go, okay, are the same things available then on a moon base? Okay, now, so the habitats we're taking a look at are 16 different ones that essentially there's ones on Earth. Notice that there's difference everything from a hotel room, a hospital room to a submarine at sea. There are habitats in space, some of them existing, a lot of them hypothetical still, like a Neil cylinder, or ones that are long ago, like the Apollo spacecraft, ones that are still to be, like a Starship spacecraft that can go to Mars, all that good stuff like that. And then we're also looking at either simulations, because we don't have any actual real habitats like on Mars or on the moon, but simulations like the biosphere or moon simulations or Mars simulations. Obviously, if you're on Earth, one of the big differences is you have full gravity, Earth gravity versus 1/6 or less gravity. Okay, so from a scientific standpoint, we're looking at, just a second. There, you don't want to hear me cough. Okay, so from a scientific standpoint, we're going, okay, what features or conditions do we compare? So one of the first things that a lot of people know if they're in this business, from the social science business, is what's called Maslow's hierarchy of needs. Yeah, it does. I think you've said that before. But Maslow's hierarchy of needs, which basically says that you're not going to be thinking about reading books if you're starving, that kind of thing. In other words, food, water, shelter, all that are going to be first on your mind before you can appreciate art and culture and all the rest, that sort of thing. Well, now it is time. In other words, that presumes, well, what units? International Standard Units, of course. No, but that presumes that you're saying that you don't have anything over on the left, times 0, to you've got fully self-actualized, over decades over on the right. And so I don't really think of it as being, sis, there you go. This is meant to be qualitative. It doesn't always have a quantitative scale. It's a relative scale of conditions, of that sort of thing, which is a difficult concept to grasp if you have not been schooled or practiced in qualitative science versus quantitative. Okay, we're also looking at, we discovered while we're doing this, is that NASA has a very, very detailed qualitative and quantitative, although mostly quantitative, in other words, they can measure, a pyramid of sorts like this that basically say, okay, you got to have it. And this is for vehicles, like the Apollo vehicle or the Artemis spacecraft or the Starship. It basically says, okay, unless your vehicle is up to snuff, forget about humans being inside it. That's level 0. And then, okay, great. What do we got to do if there's humans instead of robots inside them? That's basic needs, number 1. And then you work your way up, similar to the hierarchy of needs. And so we're looking at these as ways to be able to look at features and conditions to compare in all of our 16 habitats. Whew! Okay. The other thing is we're not just looking at, well, similar, you're right. And basically the idea is that's why, in fact, let me just backtrack a second. Okay, that's why over on the right, see, Maslow never envisioned his theory as a pyramid. Others did so that they could visualize his theory. But the way he visualized basically is said that given anyone on Earth, they may be looking more at physiological needs and then not being able to entertain in their mind, appreciate art, for example, or other or cultural practices because they're starving or they don't have water. So in other words, you need to satisfy the physiological needs, but that doesn't mean that you're not thinking about those. It's just your first thought is like, I can't breathe. Okay, so that's why the overlapping normal curves essentially over there on the right, which was actually the way it was depicted in 1949. It's just that a lot of people continued to look at the pyramid thing, which is actually incorrect as far as the way it works in real life. Okay, so in addition to, and I've got to have time for, this is kind of a warm-up to what we're doing, to what we're talking about, but we need to, okay. In addition to just saying we need water, we need air, we're trying to get down to the scientific part. In other words, why do you need air? Why do you need water? And in other words, how do our cells work? And so we've got some things where we were looking at respiration and nutrition and energy and such. In other words, why do we need all of these things? Where do we get them in physiological? So the other part is, since this is Second Life and it's not a scholarly paper, we want we want to visualize what we've been talking about, which is a lot. So we've created a very large display. It's actually 180 meters across that addresses it well and says that's exactly correct, because that's why we've posed the research question and the sub-questions. In other words, as actual answerable things. We could easily make a paper from this, or several, but at least easily make a paper. So the idea then is that we are making a 3D representation so that people can follow what we're doing. Up at the top, which some of you guys may not have seen because this is a recent addition, is that's kind of where I would plunk people who are not familiar with like respiration or research sub-questions or whatever. In other words, that's 16, different ways, numbered 1 through 16, ways of looking at what we're doing, and then ramps that lead down to visualizing each of these habitats. Let me explain. So, in the central part, we look at this from a scientific point of view, a science, people who schooled in science. And we've got the, physiological and basic needs and higher needs and research question, all that down in the center part. But, and then also, depending on whether you're quantitative or qualitative in your thinking, Sis did this one. It's a huge table that has all of the 16 different habitats and all of the different types of things we're looking at to compare the features and conditions. And it's just mind-boggling to try to take it all in. This is very large, by the way, but that's okay. This takes up like 50, 60 meters. But in order to look at it, Roy did a script, which basically, if you sit in that chair and you look at where you're looking at, and then, in other words, with your cursor, and then you click on page down, page up, you can actually zoom in. This is scripted. You can actually zoom in on what you're looking at. So if you're looking at, for example, in that SY, the milli, what's the, that's radiation. What is, alt clicker. There you go. Now, do you want to explain that really quickly, Roy, or did I explain it enough? In other words, basically, with the alt click or sit in the chair, you can zoom in. Table voyeurism. Exactly. There you go. Okay, good. Well, and that's why I want a field trip here, because just like an article in a paper, it doesn't give you the feel of the place. That's why. There we go. Okay. I'm not even sure how to pronounce that, but it's radiation. Sieverts or whatever, per year, etc. And then, methane plus liquid oxygen, solar panels, etc. In other words, Sis has researched this whole thing and put it in a big table. But for people whose eyes glaze over when they look at this stuff, we're also visualizing in a different way. Let me show you. So, like I said, there are, up on the top, there are 16 different panels which basically look like this. This is what they look like in the display. Let me show you each of the panel because there are people, Sieverts, okay, there are people in the present here who do not have an extensive background in space science or or any other science for that matter, that are just interested, and that's what the science circle is all about. Yeah, and glaze over. Very good, Sis. Okay, touche. Okay, so the science circle invites people who are vetted scientists, ed educators, but also science enthusiasts and students of learning this. There you go, amateur advanced theoretical physics. Okay, yeah, no, exactly. Okay, what tag said. Okay, so in other words, how do we express these questions that we've been looking at in a way that non-scientists, like other people that might be interested in World Moon Week, worldwide, might understand? So the question here then is, have you imagined what it's like to live on the moon? we have. And then the idea of just how different the moon is. The moon's so different from our home on Earth. How might we begin to understand just how different? Okay, so instead of the research questions and sub-questions, that's how I would approach this with people who are unfamiliar with research methodology. And there we go. Thank you, Sis. Okay, so it basically tells people we've been comparing how places we know might be like or different from home on Earth or the moon. Okay, that gives them the methodology, essentially. For example, now, yeah, I know. So, for example, at home, you're likely to have water to drink. Where would you get water to drink on a submarine or the moon? Thank you. Yeah. So in other words, posing the questions in a way that rational people basically could, that know anything about water and drinking, would understand. Okay, for example, at home, you likely can just walk outside. Okay, in Antarctica during the winter or on the moon, it's too cold to just walk outside. Now, you can actually define what cold is by going back to the table that Sis had and realizing that the average ambient temperature on the moon is minus 150 Celsius. If you're facing the sun, it's 250 Celsius above. If you're actually it's minus 50 Celsius on average at the South Pole on the moon. But it all depends on how you define where you are and what temperature is, considering it's a vacuum. We've talked about that too. And then minus 100, and then even colder inside the craters and all that good stuff like that. Well, it would, because 1/6 gravity, you could actually jump up to a second story of a building. So then we talk about, okay, on a spaceship or space station or on the moon, there's no air. Not inside. If there's no air inside, you're going to suffocate here in a minute unless you have a spacesuit. But essentially, there's no air around these. So you need to wear a spacesuit every time you go outside. Okay. So this is a way of describing what we're trying to do. Yeah, if you have beer, it'd be, and Blue Moon. Thanks, Sumo. Okay. So on a spaceship or a space station, there's no gravity. So you can't walk. But the moon has a little gravity, so you can hop or jump. Therefore, the hops on the moon. Okay. Okay. So while we try to understand the moon better, we're building 3D models of known places, these 16 habitats, to learn how they might look and feel. That's qualitative versus, how cold is cold. For example, a submarine or a spaceship may feel cramped. Now, we could define cramped as in like how many cubic meters does each crew get in their living area, or how far apart do residents of a submarine have to get to walk through this hall, the halls, which is not called a hall, it's called a passageway, that kind of stuff. But does a base on the moon need to feel cramped as well? Those are some of the, by understanding how cramped is, either at home or on a space station or a research station in Antarctica, we can then go, I don't want to be this cramped, or this is too much room, or whatever, that sort of thing. So we can actually come up with quantitative as well as qualitative measures of how we would like our moon base to be. So what we did, and it by the way, it takes a little bit of on the moon or on the Earth. Yes, now Sumo, you're correct, and that goes to the question of who should be on the moon. And it also goes to the question, when we look at these habitats, if you're a sailor on a submarine at sea in the military, your idea of why you're there and what you'll, let's say, put up with is different than if, say, you're a billionaire wanting to be comfortable and entertain their friends. Okay? That sort of thing. Or if you're in Antarctica and then the designers of the Antarctica Research Base, as they did, designed it to look a lot like an apartment building with stores and stuff, instead of being at the South Pole of the Moon. South Pole of the Earth. On the inside, it looks just like any other building on Earth. It's got a lot of space. But you couldn't do that on a spaceship because you'd need more fuel. There's practical reasons for all of these. So you're right. The sense of duty, the constriction or the restrictions due to weight and physics and money and all that. Okay. Are important. So what we had to do, we're gonna take a look at the submarine. What we had to do, and it's not easy to do this, is like, okay, show me a diagram of a nuclear submarine. Okay, you can't. It's difficult to find these things. This particular diagram, which shows the top section of 4 levels of an attack submarine, I actually found in an engineering class in a college, and they made a 1:100 scale submarine, but they did it with drawing programs. In other words, they didn't make it like the way we're doing it in Second Life. But so once you find diagrams like this, then you can actually create them in 3 dimensions. Okay, so here is a full scale. You can see my avatar there. This is a full scale middle section of an attack submarine. It represents maybe 1/4 of the size of the submarine itself. A 1/4 scale model is down at the bottom there. But you can see that if you do your homework, you can find out how to do this. By the way, the submarine is round. It's not oval shaped like that. So technically that photo there should be elongated. But since it is 3-dimensional, you can both show pictures of what it's like. So, for example, on the left is a real picture inside a submarine of sailors eating their meal. Well, and Nero, that is a question of who do we send to the Moonbase? Do we allow billionaires just because they're billionaires to go there and they funded it, even though they might be totally unhealthy and unfit to be there and can't even fit through spaces sometimes? Do we allow anyone off the street who might be claustrophobic to go in a place that's very crowded for months at a time? That sort of thing. Well, they're eating, and they don't have a lot of time to eat. So, yeah, catch them when they're doing off duty, okay? That sort of thing. But, well, Nero, you're right, and you sure wouldn't inform consents, etc. In other words, all of those sailors, if you look at them, they're all young men, because it's a submarine here. Although there are, on a typical attack submarine, there's about 150 young men and about 20 officers. Now, that's another thing. Is there any hierarchy? How is a submarine governed versus a space station? Do we consider management versus workers, etc.? What kind of governments? Elections. Well, you can elect anyone. We've seen that. Okay, but on an attack submarine, on the right is how eating is done in the newer classes of submarines. They look like basically picnic tables, and they're made to look in the colors of the state sports teams after which they're named. So, for example, there's a virtual tour of the USS Virginia, and in the eating place there, it's all made up with, or Indiana, excuse me, and so it's all made up with Indiana Hoosier colors and sports photos and stuff like that. You can also see how people sleep. Over to the left is actually an earlier submarine version, but you can see how crowded it is. It's not meant for sleeping. The submarine is meant for working. But even on the modern submarines, there is my avatar, and that's a 6-person berthing area. By the way, those are called coffin racks for a reason. That's where 6 people sleep. Now, at no time almost is there any 6 people in there. Most of the people are working, and there may only be 1 or 2 people actually sleeping in there. And by the way, it's dark all the time. I know, I lived on Navy ships for 8 years, so I know what they feel like and look like quite intimately. Well, now, Andre, if I pronounced your name correctly, that's a good question. Is the research facility is one of our models too? We're going to be studying it a little more in depth. We've looked at pictures like this of it, but we haven't made a full-scale model. But what it looks like is a lot like any place, a big building on Earth. It doesn't look like that to the left. Okay, this is a submarine. Well, Nero, you're right. Exactly. All of the things about being human, going to the bathroom, or restroom, toilet, is also tight quarters. Now, it's not as tight as, say, for example, the Apollo spacecraft or the Artemis spacecraft. The Artemis spacecraft is not even as big as this area with the 3 chairs up here, and yet there are 4 people in that spacecraft living, working, breathing, going to the toilet, dressing, men and women, for 2 weeks. So you can't just throw people who never have had any experience in tight quarters like that together, for example. Now, there's also, on a submarine, for example, there is, like I said, some hierarchy, because but it's like perhaps in a business as well. Compared to the cramped quarters of the young, and I'm talking 18 to 22 years old men, the quarter to the left there is the commanding officer, who may be in their 40s and or more, and have 20 years of experience and be in control of 175 people, life and death, and the mission of the submarine. That's the commanding officer, who I feel has earned their place to live in that place, which even then, that's not even as big as a college dorm. And the bed folds down. So, and then the officers also, their meeting area where they discuss operations and what's going on and have briefings and stuff, also serves as the wardroom. That is the officers' dining room, which looks a lot different than those tables that you saw down for the enlisted men. There are also women on board, several women on board submarines also. Not in the crowded methane? Well, yes. In other words, if you're tired, you can sleep anywhere, especially if you're young. I've done it. I used to sleep. The rack that I slept on the first aircraft carrier I was in was right next to the catapult for aircrafts taking off, and it was warm on one side. The room itself is always cold, and it's dark all the time. But that would keep my rack, which was the one on top, right at the right temperature. But I used to be able to sleep through aircraft launching, which, if you've never felt something like that, it's like an earthquake, a very loud earthquake in your house, and I used to sleep through that. So again, our latest approach is scientific. We have basically a guiding question, which we've been looking at the whole time, but we're looking at it now in kind of a scientific way. But when we say science, we're looking at it in a qualitative way. That is, what does it feel? What kind of colors? What kind of where we are? What is that what we? Well, I'm older too. I'm getting mid-70s. I don't even sleep well, no matter what it is. Okay, so it's okay. Okay, so yeah, we're still talking about farts, I guess. Okay, so anyway, the approach we're using is both qualitative and quantitative. We're posing a research question and sub-questions in a way that can be answered quantitatively, but also when we say compare, it's not just temperature in degrees or gravity in whatever gravity is measured in, feet per second or whatever. But it's, yeah, very intellectual discussion, but also a lot of fun. And so Sis wanted me to make sure that we invite people to go to the real space. Okay, if you go to the landing point here and you click on Moon base, you'll get there. It's at 1,140 meters straight above us. And you can go there, and we invite you to go there and visit yourself. Also, to go take a look, absolutely, go take a look also at the immersive experience, which we created for the Virtual World's Best Practices in Education. We'll have a field trip there when we have fleshed it out more. Yeah, absolutely, Sumo. Go see it. Go feel it. Give us feedback. What do you think? Right now, I'm trying to go just like, okay, what about the colors up there? A lot of people think they're too bright. I could make them more subtle or sophisticated, that sort of thing. Well, Sumo, that's an interesting point, is that why don't you, now we got 10 minutes, okay, because I've roared through this stuff. So why don't other people in the Moon group chime up and from where they are up here or whatever, and talk about things we're doing and how interesting it is, or things you're doing, or whatever. Waiting for somebody to talk. Oh, okay. Andre, if I pronounced your first name correctly, is that this is the amphitheater. Above us is a pavilion-looking, well, no, wait a second. A pavilion-looking structure, which has an astronaut that you can go see the immersive experience. Also on this island, there are a lot of teleport. Where's the nearest teleport hub from here? I know there's one over by the planetarium and the big ship and stuff, but if you go over there, you can, yeah, okay, where you TP in, there you go. Okay, there's a teleport hub, and if you click on Moonbase, you'll go to the place where, let me see if I can find the right slide here. I'm just guessing which one it is. It's not that one. Anyway, I'm guessing which one it is. Going backwards here because I don't have the thing with me. But the idea is that if you go up to the moon base, you can see what we're doing. What do you mean project the images on? Oh. Movies? Oh, hey, that's no problem. You can show videos on Prims. In fact, what I think I'll do for the submarine is you can take a full tour of the submarine from YouTube video, You could also look at a full tour of the Antarctic base, all of that. Okay. Anyone else? Any questions? Any want to talk about more about what we're doing? Doodly doodly doo.
I might jump in here, Phil.
Please.
Yeah, I just want to make sure everyone understands that when you go to the exhibit, of course, it represents a work in progress. So that we're trying to figure out the best way to organize the comparisons between different habitat types and figure out the right kinds of questions to ask and eventually get the right kinds of answers. The table that I created is huge. It has the advantage that everything's there, but the disadvantage is that there's so much in there that it's kind of difficult to follow. The table will never really be finished because there are always more rows you can add, different things you can compare, different qualities, characteristics that you can compare, and you can have another table. There's another table I'd like tagline to help with is that we have a table that lists the different kinds of human needs, psychological needs, somatic needs, and have those listed very clearly. I mean, there are NASA publications which have something like that there, but we want to put it in a form that people can understand and appreciate. And there are whole kinds of things we can do. We can have the tables we could have where you click on the table and it produces a subtable of just say a couple of particular columns that you're interested in, or a couple of different rows that you're interested in, things like that. There are many things that we can do that allow us to examine the information that we have and compare the different kinds of information we have in different ways to come to a real sense of what it would be like to live on a moon base or in any of these other habitats, because this also helps us understand who we are as human beings. So I think this can be very exciting when it's as we progress with this.
Okay, so my keyboard was acting up again. In any case, the type of things which you're talking about, where you're talking about, okay, keeping in touch with Earth, having simultaneous movie nights, why not? You know, anything like that is possible. Even the idea of a movie night. Why would we have a movie night? What would be the purpose of having a movie night on the moon? You can speak in voice if you want, or type, or yeah, socializing. Now, social interaction, absolutely, and something normal feeling. The moon is not normal feeling by a long shot. That's one of the things we learned. So social action, not only with people that you live and work with in a different venue than working and living. Well, no, that's a good point. What kind of fun do you have on a submarine? Movies. Okay. Bingo. Reading. I mean, you know, doing, what do they call it? Fantasy football. You know, people, do you know, by the way, on the video, I encourage you to look at the video for how living on a submarine, for example. Let me find it here. But for example, I was surprised as all get out when I looked at and found that some of the controls, because they're very young people, is some of the controls, and I'm not saying young people are the only ones that do this, but for example, and I'm trying to find this, there we go. Okay, is some of the operations on the submarine are made with Xbox machine controllers. Why would you think that? I mean, that sounds really strange, but if you look on the, let's see. Here's, okay, there you go. Whoops, okay. So absolutely, they're ergonomically designed, and there you go, Dolly. So why, there's the you can see an entire tour of the submarine. So the purpose, why would...
We really run our business.
Whoops. Okay. So why would you use the controllers also? Who is using the controller? Who is probably using the controller? Yeah, well, not only people who are familiar with the controller, but people who are intimately familiar with the controller, who probably do gaming in general, younger people who are very familiar with Xbox controllers and that have really, really good hand-eye coordination with them. In other words, very fine, tuned, very rapid response times, that sort of thing. So it makes sense to do operations which have the same similarity with a controller which you don't have to train anyone on because they're already very familiar with it. And I think whoever thought of that is brilliant because why not? It's got all kinds of different functions. You could program it, all of that. Okay, and we only have 3 more minutes. Are there any other for people, Emmelock or D or Day or let's see, whoever, tagline, any other? Anybody else want to chime in on why you come every Monday? Well, I don't know. I would only be 20 years younger if I had the knowledge I have right now. I wouldn't want to go back 20 years and lose everything that I've learned in 20 years. That would be really... Okay, so anyway, we have 2 minutes. I'm going to quit here in 2 minutes. Okay, so anyway, we're going to continue. What I always like to, for any meeting or whatever, I always like to say, okay, this is what we're doing, or this is what we're going to do. This is what we're doing. Not just, how about 3 cheers for the Moonbase? Okay. Well, there you go. Okay, that's a good line, Nero. In other words, people take it both seriously and unseriously. As I mentioned, is that we should be having fun with this. This is a lot of fun, and it's something real. I mean, people are planning to spend billions of dollars and risk their lives to go back to the moon. By the way, let's see. One of the things that I'll share, which is kind of interesting, is that coming up this week, I like to, and I've got 1 minute to share this, is one of the things I do in First Life is I go over to an assisted living center where, the average age is probably 80 or something. And I try to get people to think about things in the past and think, period. And then, back in the Apollo days, etc., and about other types of things. Why do we call the days of the week what we do, all kinds of different ways to think. Well, I happen to find that one of the people there, who's 89 this year, was the assistant flight director at Houston Mission Control for 50 years, from Project Mercury up through Space Shuttle. And he was there for Apollo 11, Apollo 12, 13, 14, all of that, and talked to the astronauts and made the decisions they did for Apollo 13. And he has some wonderful stories to tell. He has the original flags from Mission Control on Apollo 8 and 11 in his room, and some other stuff from Apollo 13. And so next week, we've got a press event, more or less, where he's talking. There's another guy who was up in space taking pictures, and I'm kind of in the middle, talking about us going back to the moon and stuff like that 50 years later. But it's amazing. I'll have to share some of the stories, perhaps, that he shows. He's got pictures with, Neil Armstrong and Lovell and all of those people during that time, and I'll have to probably make up a presentation to show you some of what his stories are from that time period. We don't want to lose those kinds of stories. Okay, so thank you all for coming, and please go visit the, yeah, I think it will be. Okay, please go visit, and I have to prepare for that next. Okay, what I'm going to say. So please go visit the exhibits, both the one about our new Moonbase exhibit and the one that says Moonbase, also immersive experience, and all that good stuff. Yes, they were, and to actually get a feel for it, you kind of have to be there. I mean, it's amazing. Okay, take care. Thank you. Bye-bye. Go Phillies.